All right, so we are on to RC circuits. When I first learned RC circuits, I thought that my professor was talking about RC cars, like circuits for an RC car, so I don't want that to happen to you. I want to explain what an RC circuit is before we get into it. So let me just go ahead and pull out my pen here. So an RC circuit is really just a resistor capacitor circuit, okay? And all that means is that it has a resistor and a capacitor in it. May contain multiple resistors, but will definitely only contain a single capacitor. That is the definition of a first order circuit. So I've been talking about first order circuits. Well, I haven't been talking about them by name, but I've been talking about them as part of the title of this module being energy storage elements and first order circuits. And so a first order circuit is basically a circuit that contains one storage element or one energy storage element. Okay, and so if I have a circuit that has one capacitor or one inductor, that is a first order circuit. If I had a circuit that contained multiple capacitors, multiple inductors, or capacitors and inductors, those would be higher order circuits. So an RLC circuit, which looks like this, right? It has a resistor and a capacitor and an inductor. That would be a second order circuit because it contains two energy storage elements, okay? So an example of an RC circuit would be something that just looks just like this. I got a resistor, got a capacitor, and I can connect the source here. And maybe I'm interested in the current flowing in this RC circuit. Maybe I'm interested in the voltage across my capacitor. We're no longer looking at just plain old DC circuits when it comes to RC circuits. What we're going to be looking at is what's called the transient response to some input for RC circuits, for RL circuits as well. We haven't gotten there yet, but that's when we talk about inductors. But we're no longer just going to attach a voltage source here and call it a day, and then look at everything in the operating point in terms of, well, what's this voltage, what's that voltage. Rather, what we're going to have is we'll have a voltage source here or some other type of source, and we're going to have a switch. And initially, when that switch is open, there's no current flowing in the circuit. There could be some initial condition on the capacitor. Maybe it's charged, maybe it's not. But what happens when I close the switch is some sort of transient response. And we're interested in figuring out what that response is for capacitors in RC circuits and for inductors in RL circuits. And so what we're going to be doing is we're going to be basically plotting the voltage as a function of time and the current as a function of time in these circuits, and kind of looking at kind of what happens when we connect such an input to such a circuit. Okay, and so that's sort of the brief introduction to RC circuits. I didn't have a slide prepared for this, so that's why this was just a blank slide. But in the next lecture or the next video, I am going to look at a circuit just like this one, and I'm going to derive the equations that we're going to use to determine what this behavior will be. What will the voltage look like as a function of time? What will the current look like as a function of time? We can determine that using math and using a circuit just like this, and we can derive it using KCL and some of the other things that we've learned up to this point. Okay, so I'm going to go ahead and stop this intro to RC circuits right here, and in the next video I'll derive the expression just as I said I would.